Hello, my dear students. Welcome to the IMS GATE Academy. How are you all? Everything great? So, have you enjoyed the yesterday's session of measurement? That is a part one. Part one has been already discussed on the yesterday's session. In that, we have discussed around the 4 chapters, isn't it? So, I hope all of you have enjoyed that session, and in which we have solved a number of questions, and I must say that all questions are very, very excellent. All right. So, how many of you have enjoyed? Just say hi. Yes, sir. We have enjoyed like that. Okay. So, as you know that we are about to start the measurement part 2. So, in this we are going to cover the leftover chapter which I told you on the yesterday's session. Alright, so basically in this session we will cover a CRO and your instrument transformer, potentiometer, like that, okay, and the Q meter. So, we will going to cover the entire syllabus of the measurement. Alright. So, how many of you are eagerly waiting to start the session? Please let me know. I am seeing that we have a less number, means there is a less number of likes. So, please mark your attendance by hitting the like button. Alright. So, how many of you want to start the session directly? Or if you have any doubt, then just please let me know. I will rectify or clarify all of your doubt. Whatever doubt you are having, please let me know regarding the yesterday's session. Good evening, Vipin. Okay. So, as you know that this is a GATE score booster session which is going on, and from the past days we had started this session, or you can say Gopal Rao. Good evening, Gopal. Jay Prakash, good evening. So, we have started this GATE score booster session from a past couple of a week. So, in that most of the subject has already been covered, like mathematics, you can say network, control. So, most of the subject has been already completed. Good evening, Delhi. So, basically whatever chapter we are left, or not a chapter, we can say the subject which are left related to the respective stream, we will going to cover all those subjects in a December month itself. All right, and you can find the schedule in the description box. All right. So, part 1 means, as I told you that part 1 has been already covered, and this is the part 2 in which we are going to cover the leftover subject. All right. So, shall we start? Shall we start? I hope everything is clear. Okay, Jagdish, good evening. Good evening, Jagdish. All right. So, shall we start? So, here comes the first chapter of the today's session is this CRO, and this is, mind you, this is one of the important chapter, whether you belong to EE stream or you belong to IN stream. This is very, very important chapter, because out of the 4 marks, if I talk about the electrical stream, out of the 4 marks, definitely you are going to have at least 1 marks from this chapter. Am I clear? So, this is very, very important. CRO means what? Cathode ray oscilloscope. Anyway, we are not supposed to discuss whole chapter. Rather, we are supposed to revise the whole syllabus related to CRO through the question. All right. So, let us see the important topic in this chapter, which is YT plot. All right, and the frequency measurement from XY plot. So, what is YT plot? In the YT plot, we give the unknown signal at the Y plate and the time signal to the X plate, and we will going to observe our unknown signal, whether the unknown signal is sinusoidal, cosine, rectangle, triangle, any kind of signal. Okay, so we can observe those unknown signal in the YT plot. All right, and from there we can measure amplitude, your frequency, your RMS value, like that. All right, and many more. Now, coming back to this frequency measurement, so from frequency measurement from XY plot, what it means? XY plot is also known as the Lissajous figure. All right. So from the Lissajous figure, we can find the unknown frequency of the signal, which is unknown signal, and the unknown phase angle, or you can say the phase angle of the unknown signal. So by using this XY plot, we can find these two parameters. So let us directly jump to the question. So here comes the question number 1 of the today's session. So read the question very carefully, because this question consists of two subjects. The first one is control system, which has been already covered by the Ankur sir, and the measurement, as you know that I am taking this one. So this question is basically the combination of the two subject. All right, so read the question first, and this is NET type of question. A negative unity feedback control system with OLTF as K upon S plus 1, S plus 2, S plus 3. This is very, very important transfer function. All right, so means you can say that this is a very what to say, lovable kind of transfer function for the GATE authorities. Means if you expect the question from the transfer function in a control system, definitely you may come across this OLTF. All right, so moving ahead, this is transfer function is found to be marginally stable with the frequency omega y. Two sinusoidal input are applied to y and x plates of the CRO with frequency omega y and omega x respectively, and the following Lissajous figure was observed on the screen shown below. The value of omega x is radian per second rounded up to 1 decimal places. So whatever answer you are getting, you should round off those answer to 1 decimal place. All right, now see here, this is a CRO screen and this is the boundary of the CRO. Please do not consider this corner, this boundary as a part of the Lissajous figure. It is not like that. This is the boundary of your CRO screen. Am I clear? So whatever figure we have inside this boundary is known as a Lissajous figure. So basically from here we come to know that this is XY plot. All right. So here we have a omega y. This is a frequency where system is marginally stable. Okay, at this frequency. And just a second, let me change this pen. All right. So this is marginally stable at a frequency omega y. Done. And we need to find the omega x. So omega y is the frequency of the unknown signal, and omega y, where y implies the frequency which is applied at the y input, or you can say at the vertical plate, and omega x is what? This is the frequency of the known signal, KNOWN, known signal which is applied at the x plate or the horizontal plate. All right, so let me give you 1 minute for this. 1 minute for this, or if you want to some extra time, then please let me know. Let me give you 1 minute for this and try to solve within a minute. All right. Did you like the question? Please guys, please tell your friend to join the session, because we are going to have a good session and a great session definitely. All right, so please inform your colleague or student community wherever you are connected to at least join the session, so that we will having a competitive or a healthy competition during this session. All right. So do you want more time? Then please let me know. Otherwise, I will directly start the solution. Done. Do you want more time? If you want, just type 1 for 1 minute. If you want 2 extra minute time, then type 2. All right. Otherwise, I will directly start the solution. So let me close this timer. All right. So how we will going to find? Basically, this is a negative feedback system in which this is the transfer function. Okay. So let me directly come to the solution part. Our sorry, g of s is given as k upon s plus 1, s plus 2, and s plus 3. Alright, so k can be positive or negative, but if it is not mentioned in the question, then by default we will take k to be greater than 0. Am I clear? And the feedback is what? Unity. And this is negative unity feedback. Done. Now we need to find the transfer function, which is CLTF, closed loop transfer function. Am I clear? Any doubt in this? So see here, this is equal to what? G of s upon 1 plus G of s H of s. I hope this thing you are know, because this is already covered by the Ankur sir, so I am not going into in detail, otherwise it will going to kill the time. Okay. Anyway, moving ahead, this G of s is given to us, which is k upon s plus 1, s plus 2, s plus 2, s plus 3. Just a second, guys. Okay, guys. So see here, this is k upon s plus 1, s plus 2, s plus 3. All right. So this is G of s whole divided by 1 plus k upon s plus 1, s plus 2, s plus 3. Now when you solve this, you will get k upon s plus 1, s plus 2, s plus 3 plus k. So this is the closed loop transfer function. Done. All right. So moving ahead, the closed loop transfer function, the denominator part is known as characteristic equation. Am I clear? Known as characteristic equation. All right. So this is what? S plus 1, s plus 2, s plus 3 plus k. So when you expand this factor, you will going to get s cubic plus 6s square plus 11s plus 6s plus, sorry, not 6s, 6 plus k. Now one more thing here, the stability of the system is decided by the open loop of the or you can say the numerator of the CLTF or the denominator of the CLTF. The stability of the closed loop system is decided by the numerator of the CLTF or the denominator of the CLTF. Everybody please answer. So closed loop system stability is given by denominator or numerator? It is given by the denominator. So this is what? This is your denominator part of the CLTF. All right. Now this is s cubic plus 6s square plus 7s plus 6 plus k. This is the characteristic equation that we have. Now let us form the RH table, because from the RH table we are going to see whether the system will going to be stable or unstable or marginally stable. So for that, let us frame the RH table. So we will start from the highest power to the lowest power. So s cubic, s square, s power 1, s power 0. So take the first coefficient, then after that leave 6, then 11 will come here, 6 will come here, 6 plus k. All right. What about s plus 1? Multiply this 66 minus multiply this 6 plus k whole divided by this value 6. Here 0 will come and 6 plus k directly come here. All right. Done. So these are the part from which we are having the RH table. All right. Now how to find the system stability? For the system stability, there should not be any sign changes. Means if the system is stable, there should not be any sign changes. So if this is plus, then all value has to be plus. And for the unstable system, we should have at least one sign change. Then what about marginal stability? In the marginal stability, we should have a row of zeros. Row of 0 means one row will become completely 0. All right. Now, if you see here, this is first row, second row, third row, and fourth row. Can this row, can this row will ever be 0? No, it will never be 0. All right, sir, K value be 60 for the marginal stable. Yes, excellent, JP, excellent. So, for the row of 0, it should occur. Let me change the color. For the row of 0, the odd row has to 0. All right. And wherever we are having the row of 0, just above to that row, just above that row, is known as auxiliary equation. All right. So moving ahead, let me add a page over here. So moving ahead, what we have at row of 0, we have 66 minus 6 plus. Now, whenever you put a row of 0, you will get K as a K marginal. Means your K will become K marginal. So, omega value will be root over 11. Excellent, JP. Excellent. So, you have already completed your 50 to 70%, you can say, the solution part of this question. Okay. So, please give me the answer, JP, and others also please try. All right. So, moving ahead, when you equate it to 0, you will get the K value as, or K marginal value as 60. Done. Now, how to find the omega y? How to find the omega y? So, for that, we will use the auxiliary equation. What is auxiliary equation? That is 6s square plus K marginal. You have made this auxiliary equation by choosing K value such that it will become row of 0. So, for that particular case, your K will become the K marginal. So, 6x square, and we are leaving the alternative rows. No? We are leaving the consecutive rows. So, because of that, 6s square will come here, and s to the power 1 we have to be leave. Then after that 6 plus K will come. All right. So, moving ahead, this should be equated to the 0. What is K marginal? K marginal here is 10. Is it correct, or I have done some mistake over here? Sorry, this is 60. I think I have done some mistake somewhere else. Okay, this is 66, 6 plus K. Extremely sorry. This is 6 here. This is 6 plus K marginal is 60 equal to 0. So, this will be 66 equal to 0. So, S square will be equal to minus 66 by 6. This is equal to minus 11. What is S? S is J omega whole square. This will be minus 11. So, J omega will be equal to plus minus root over 11 J. Because of negative sign, we will be having the imaginary part. Now, under this situation, whenever your system is oscillating means it is having the sinusoidal term in the time domain, the transfer function will have the response term will have your sinusoidal function or a cosinusoidal function like that. So, cos omega, so in that omega will be what? Natural frequency. So, this omega is basically what? Natural frequency. All right, done. So, here omega n will come equal to plus minus j root over 11. Now, the definitely one question should raise your mind is that, sir, S is what? Sigma plus j omega, na? S is what? Sigma plus j omega, but you have written j omega. What is the reason that I have written j omega only? The reason is, whatever analysis you are doing, that is the steady state analysis. Am I clear? So, in the steady state, there should not be any transient part, and this sigma will give you the transient part. So, because of that reason, this sigma has to be neglected, and this S is replaced with the j omega, and n is what? Natural. So, natural frequency. Anyway, moving ahead in the question, this omega n is written as given as omega y, isn't it? And this is equal to root over 11. Done everyone? Any doubt in this? So excellent JP, excellent. So let us move ahead. Now we need to find the omega x value. We need to find the omega x value. So how to find that? For that we will use this CRO. Alright, we will use this CRO. Now how we will going to use? Whenever you are supposed to find the frequency or the ratios of the frequency or the unknown frequency, we will use the XY plot, in which we will be having the two method. First one, tangent method, and the second one, that is cuts method. Anyway, I will take only one method, that is the cuts method. So what is cut method here? See, take only this inside wala diagram. Take only this the diagram which is under the boundary. All right. Now draw the horizontal line such that it should not pass through the pre-existing intersection. So what is pre-existing? See here, this is a pre-existing point. This is again pre-existing point. This is again pre-existing point. So you cannot pass or you cannot draw the horizontal line like this. Otherwise, you will going to get the wrong answer. So for that particular reason, how we will going to draw the line then? Like this we will going to draw. All right. Now see here how many cuts we have. 1, 2, 3, 4, 5, 6. So we have horizontal cuts. Let me write in short manner. Horizontal cuts is how much? 6. Now find the vertical cuts such that it also not pass through the pre-existing. So here we have a pre-existing cut. All right. So it should not, means the line should not pass through this pre-existing point. Then how we will going to draw the line? So we can use this line. Okay, I hope this color is visible to you. है ना? This color is visible na? Okay, great. So we have one intersection here, two, not intersection of cuts, you can say 3 and 4. So your vertical, this is vertical line, na? Vertical cuts, this is equal to 4. Am I clear? Now here Fy by Fx, this is the formula, Fy by Fx. Now here in the numerator, horizontal will come or vertical will come? Please let me know, anyone? Here in the numerator part, the vertical cut has to come or the vertical cut has to come. So for that, let me give you a good trick, because most of the time student get confused whether here horizontal will come or vertical will come. All right. So for that, let me give you one shortcut. This is an axis, and that the horizontal we usually keep as a x-axis, and vertical we usually keep the y-axis. So this is horizontal. This is vertical. Na? Vertical cuts into. Let me write here. Vertical cuts into. This is y-axis. So Fy. This is equal to horizontal cuts into x. Any doubt in this? So this is the short trick in which you will going to remember this formula, and definitely you will not from now onward you will not going to forget this shortcut or formula, you can say. So basically this Fy by Fx is here, then definitely horizontal cut has to come here and vertical cut has to come here. All right. Now multiply with 2 pi in both numerator and denominator. What we have? This will become omega y, and here it will become omega x. So horizontal cuts we have 6, vertical cuts we have 4, and omega y we have got as a root over 11 divided by omega x. This is equal to 3 by 2, isn't it? 3 by 2. So your omega x, this is equal to 2 by 3 into root over 11. So on solving this value, omega x, anyone please give me the answer. Anyone please give me the answer. I am getting 2.2 radian per second. Any doubt in this? Do we have any doubt in this? Please let me know. How is the question, everybody? Did you like the question? And guys, please inform your friend to join the session as fast as possible. Otherwise, they will lose a very good session. All right. So please inform the student community, or you can say your friend, so that they can join as early as possible. So I hope you have enjoyed this. You have enjoyed this question. Now let us move ahead with the next question, which is question number 2. And this is MSQ type of question, a multiple select question in which we may have more than one option as a correct option. Determine the phase difference of the following waveform observed in oscilloscope. This is a axis. This is a vertical and the horizontal axis of your CRO, and this is two waveform. You can say this is two sinusoidal kind. You can say a kind of sinusoidal function. All right. And we need to find the phase difference. Done? Clear? So do I have answer for that? Please reply, guys. How to find this answer for this particular question? All right. Now see here. See here, if you move this diagram, if you shift this two diagram towards the right hand side, such that this point come here and this point will shift here, isn't it? Because this is one division and this is a kind of half division. So this will start like this, okay, and this will be like this. Done. All right. So this is what? This difference is what? This difference is a phase difference, which is phi. All right. Otherwise, let me give you a good idea about that how I have written here phi. Assume that this phase or you can say the waveform. This waveform has not started from here. It is starting from here, like this. Means both are overlapping to each other. Then in that case, what is the phase difference? Then in that case, what will be the phase difference? Definitely the phase difference will be 0 if both are overlapped to each other. But my question is, I need to find this phi. How are we going to find? How I will going to find? Now see here. This for one complete waveform, how many division that waveform is covering? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 10 division is basically what? 10 division is basically what? This is the one complete cycle. So one complete cycle means how many degree? One complete cycle means how many degrees? Sir, ये GATE के लिए important है. Yes, whatever session we are taking, whatever subject we are taking, whatever question we are taking through GATE score booster, all are very, very important. Mark my word, through from this concept or whatever concept till I have discussed or the faculty has already discussed, definitely you will going to have the question from those concept only. All right, am I clear? So this is how this session is important to you. All right, let's explore UPSC IAS. All right, so moving ahead, this is the phi which I am supposed to find. Answer is B and D. Okay, JP, let us see. So one complete cycle means how many degree? 360 degree. Done. But I want this phi. This phi is covering how much division? 1 and 0.5. This is a 0.5. This is 0.5. So 1.5 division means what? 1.5 divided by 10 into 360. So this will be equal to 54 degree. Am I clear? Any doubt in this? So one answer is what? 54 degree. Done. But 54 degree, this is in anti-clockwise direction. This is in anti-clockwise direction. Now, if you want this angle in a clockwise manner, so you will have to move in this manner, in this direction. So, if you subtract, suppose this is your 54 degree. This is your 54 degree. All right. And this is one complete angle, which is 360 degree. So, what I need to find? I need to find this angle, isn't it? I need to find this angle. Let us say this is theta. So, how to find? Theta plus 54 degree is equal to 360 degree. So, theta will become what? 360 minus 50, 310 minus 4, 306 degree. 306 degree. But sir, here you have written plus, but the answer here is negative. Means this option is correct. Why? Because for the anti-clockwise, we will have to take the plus sign, and for the clockwise, we will have to take the negative sign. Basics of your complex variable. All right. So excellent, JP. You have got the correct answer as an option B and D. Excellent. Excellent. All right. So I hope you have got the concept. Any doubt in this? Shall we move ahead? Let us move to the next question. This is again one of the important question, and definitely this question will test your preparation level. Means how you are prepared for the GATE exam, how much you are prepared for the GATE exam, this question will going to test. Am I clear? So basically by looking into the figure, it looks like a kind of challenging or a difficult kind of question, but mark my word, this is not the case. If you have a concept, then definitely all question will be easy to you, and if you don't have a concept, then the easy question will become a challenging and difficult for you. Okay, my friend. Now see the question first. For the given circuit, the voltage waveform displayed on the CRO across the resistor R equal to 10 kilo ohm present in the branch AB will be. Consider ideal op-amp and PMMC voltmeter. Alright, so this is a kind of circuit which is given to us. This is an op-amp that we have. Alright, and this is a bridge from the measurement. So op-amp we have, we deal in which subject? Jay Prakash, let's explore, Gopal, Vipin. Alright, so this op-amp, in which subject we used to study? We used to study in analog. So basically this question consists two subject, analog plus measurement. Alright, so let me give you three minutes for this, because this is a lengthy question. All right, so analog circuit, excellent, excellent. So let me give you not a 3 minute, let me give you a 2 minute. So in that, try to solve this. All right, so let me start. Let me give you a hint. Whatever op-amp you are seeing, that is a stable multi-vibrator. That is an astable multi-vibrator. Okay, extremely sorry. Extremely sorry, Rupesh and JP. Is it fine now? All right. So by looking into this circuit diagram, this op-amp wala, this is basically what? This is unstable multivibrator. What is unstable multivibrator? The unstable multivibrator is a vibrator or a kind of vibrator which will have a fixed output as a plus saturation voltage or minus saturation voltage, and the output are changing for a fixed amount of interval of time. Am I clear? So the interval is fixed, the time period is fixed. For a half time period, the output will be plus V set, and for the other half period, the output will be minus V set. So what is minus V set and plus V set? That is a saturation voltage. All right. Now one more thing, we have this diode. This is not a normal diode. This is a Zener diode. All right. So this is a question which is related with the unstable multivibrator, with a Zener diode and a bridge. So we have lot of concept which is required for this question to heading toward our solution part. Now how to solve this? So I will take one by one part, and we will going to see how we will going to approach for the solution. Now one thing for sure, we need to find the voltage across the branch AB. Where is AB branch? This is A and this is B, and this is the resistance connected between those two branches, and we have here a voltmeter. We have a voltmeter which is PMMC. So what I need to find? I need to find the voltage across this R element. Saurav Upadhyay. Hello Saurav. So here we need to find the voltage across this A and B point. Done. So how to find this voltage? This bridge can only be work when we have a supply, isn't it? When we have a supply. So do we have a supply given for this question? No, we are not directly given the supply voltage here. So if you look into the figure very carefully, you can see that whatever output of the op-amp we are getting, whatever output we are getting from the op-amp, those output will act as an input to this bridge. Am I clear? All right. So let me take this unstable multivibrator first. Okay, this is the unstable multivibrator first. So before that, let me add one page. So unstable multivibrator. Done. So we have a diagram like this, minus, plus, this is grounded, and we have a capacitor over here like this, and a resistance here, and this is the output, let us say V01. This is the output of रुपेश सर, क्या इस तरह का क्वेश्चन डबल ई वालों को भी आ सकता है? डेफिनेटली आ सकता है रुपेश, मतलब इतना लेंदी क्वेश्चन तो नहीं आएगा, क्योंकि मैंने ये क्वेश्चन इसलिए बनाया है ताकि आपका एनालॉग, पावर इलेक्ट्रॉनिक, मेजरमेंट सब कुछ कवर हो जाए, लेकिन डेफिनेटली इसका कुछ पोर्शन जो है आपको एग्जाम में मिलेगा. एम आई क्लियर एवरीवन? सो ये तो आईएन लेवल का क्वेश्चन है. हाँ, आईएन हो या डबल ई हो, आप क्वेश्चन देखोगे तो लगभग लेवल सेम रहता है. Okay, so let us move ahead. Done. This is the resistor R. Now this is the unstable multivibrator. All right, and what else we have? 5 kilo ohm and 5 kilo ohm. All right. So let me take this as R1 and this as R2. Done, Rupesh? All right. Now see here, let me take this voltage as Vc of t. And what about this at the non-inverting terminal plus? This is a non-inverting terminal and negative is what? Inverting terminal. So whatever voltage we are getting here, that is apply the voltage division rule. Means it is given in the question that op-amp is ideal one. So no current will come here, no current will enter here. So the total voltage from this point to this point is V01, and this voltage is basically what will come here. All right. So what is this voltage? Please let me know in terms of V01. Apply KVL. So this voltage will be, let us say this as Vx. So Vx will be equal to R2 upon R1 plus R2, and total voltage is V01. Done. So this R2 upon R1 plus R2, this is what? This is beta. So here Vx is what basically? This voltage. Okay, I am not going into in detail, otherwise it will going to take 1 hour or a 1.5 hour like that. So we don't have that much amount of time. But anyway, this topic, or you can say the topic related to this portion will be taken care by the Gopal Rao sir, and you can find the schedule in the description link where the for the particular date where he will take the analog subject. All right. So this particular topic will be handled by the Gopal Rao sir. All right. So moving ahead, this is beta V01. Look at here, everybody. Okay. Now see, this is this VCT and Vx. So let me take this difference here, Vd. This difference is Vd. So Vd is what here? Vd will be equal to Vx minus Vc of t. Vx minus Vc of t. Now, during the positive half cycle, or you can say during the first half cycle, this capacitor will charge through this resistor. Am I clear? So the capacitor will charge through this resistor in this manner. All right. So for that particular reason, if it is charging, then this Vd is greater than 0. Whenever your Vd is greater than 0, your output will clamped to plus Vset. Will clamp to plus Vset like this. Now look at here, everybody. This is beta Vset1, and definitely this will be less than 1. This will be less than 1. So this Vx definitely will be less than V01. So this is what basically? This is V01. So let me take this Vx as a reference, which is this one. Definitely this Vx will be less than V01 like this. Now this capacitor will charge, and whenever it will go till beta V01, whenever the capacitor touches beta V01, this will become 0. This will become 0 because this is fixed now. This Vx is fixed. This capacitor is charging. So whenever it will go, this capacitor exceed this Vx, this Vd will become negative. This Vd will become negative. So as soon as it will become, it will exceed, this capacitor will exceed beta V01, your output will change to this value. What is this value? Minus V01. Minus V01. All right. So from here, the capacitor will now discharge like this. So this value is what? Minus beta V01. For the positive saturation, and this is minus negative saturation. All right. So this is for the plus Vset, and this is minus, extremely sorry. This is minus Vset. Now whenever, see, now as soon as this capacitor will going to exceed this minus beta V01, this Vd will become positive. This Vd will become positive. All right. So whenever this Vd become positive, your output voltage, this V01, will again jump to positive Vset, like this. Then again minus Vset, like this. So what actually is happening here? What actually the thing is happening here? Due to the charging and discharging, here the capacitor is charged. In this region, the capacitor is discharging. So due to charging and discharging, the output voltage of the I-stable multivibrator is changing. All right, and the output voltage is fixed to plus Vset and to minus Vset. So from here, the waveform will be like this. Okay, so this is capacitor voltage. Extremely sorry. So this is capacitor voltage, Vc of t, or you can say Vc only. Achha, we have written Vc of t, na? Okay. Done? Clear, everybody? Now, what is this time period? This half time period? This is the total time period t, and this is given by 2RC. This R into C, natural log 1 plus beta upon 1 minus beta, and this is the beta value. This is the beta value. All right, and this half period is basically what? This is t by 2, and this half period is t by 2. All right, because the charging and discharging time period are fixed and it depend on the RC. Am I clear? Rupesh, Saurav, JP, Gopal, everybody. All right, so this is the glimpse of your stable multivibrator. All right, am I clear? So what next we have? Now we have seen that the output voltage has fixed to plus Vset to minus Vset. All right, Rupesh. So let me add one more page for the Zener diode. All right. All right. So the Zener diode is different from the conventional diode or a normal diode. Okay. So as you know that it represented like this. This is a normal diode, and if you put slash over here, it will become Zener diode. All right. So the Zener diode is what? Basically it is acting as a voltage regulator. It is acting as a voltage regulator. So let us take the voltage of this Zener diode is Vz. All right. So your Zener diode will operate in 3 regions. How? The normal diode will operate in 2 regions, reverse bias and the forward bias, whereas Zener diode will operate in 3 regions. So in the first region, whenever you have plus sign here and negative sign here, okay, which is following this symbol. So in that case, the direction of current will be like this, isn't it? And in that case, what we have, your Zener diode will be forward biased, and it will act as a short circuit in that case. Done? All right. Now next, when you have a current in this direction, when you have a current, means not this one, let me rub this part, in this direction, then what you have, just a second, let me remove the redundant thing. Okay, so when you have a current in this direction, so from here plus will come and negative will come here due to the direction of the current. All right. So in that particular region, if you see that, means for this particular direction, you see that the direction of diode or a direction of Zener diode and the current both are opposite. So if both are opposite, the region will be shifted to the left hand side. So till VZ, let me take this point as VZ. The diode will be from here to here. It will be open circuit and it is known as reverse bias region. Here it is acting as an open circuit and it will be in a reverse bias region. Now once this VZ has been reached, everybody please listen me very carefully. Once this V of Z has been reached by the Zener diode, then it will act as a voltage regulator. It means that your voltage at the generator will going to be fixed as a value of Vz. So after that, this region will be termed as avalanche region, or you can say avalanche breakdown. Avalanche breakdown. Okay, this is the phenomena which is known for the voltage regulator. All right, avalanche breakdown, and the region is known as breakdown region. Breakdown region. All right, so in that region, whenever your voltage exceeds this Vz, your voltage will be fixed. This Vz will be fixed. Am I clear? So your Zener diode will operate in three regions. In the forward bias, it behaves as a short circuit. In the reverse bias, between 0 to Vz, it will act as an open circuit. And once it exceeds the Vz, it will behave as a breakdown region. So moving ahead with the solution part, okay, we come to know that your output has been fixed. Your output has been fixed. All right. Now let me take the first case. Everybody please listen me very carefully, because this is a very, very important question. All right. So let me replace the thing which are not at all required here. Just a second, everyone. Please give me some time. Okay. Now, see here everyone, during, just a second. Okay, see here, case 1. Case 1 means when output is plus Vset. As I told you, your output will going to be, your output will going to be clamped to plus Vset to minus Vset. All right, now if you look into the problem, your plus Vset is plus 10 volt and minus Vset is minus 10 volt. Am I clear? Okay, so plus Vset will be fixed to plus 10 volt. So this voltage is what basically? This voltage is plus 10 volt. Done? Clear? Now, the operation now depend on this Zener diode. Whether this Zener diode is operating in a forward bias region, a reverse bias region, or a breakdown region. Am I clear? So see, we have given Vz as 8.3. We have given Vz as 8.3. Now, if this Zener diode voltage exceed 8.3, then 8.3, then it will behave in a breakdown region. And if it lies between 0 to 8.3, it will act as an open circuit. And if it will have a positive value, just like your normal diode, or means the voltage across the Zener diode is positive, then it will act as a short circuit. So for that particular reason, what we need to check? We need to check in which region this diode is operating. Now everybody look the board very carefully. What I will do, I will assume Okay, I will assume this Zener diode to be in, just a second, Zener diode to be in off state. All right, off state means I have assumed that my Zener diode is that is open circuited. All right, this is plus minus V10. All right, so off state means this is open circuit, means this is open circuit. And if this is reverse bias, then definitely this part will have a plus and this part will be negative. This part will be plus and this part will be negative. Means let us assume here voltage as what to take? Let us take V1. Let us take V1 here. Means I have assumed the voltage across the Zener diode as a V1 by considering that is in off state, and we are means we are supposed to check this V1 value. Now for that, how we are going to find this V1 value? How we are going to find? Now for that, let me simplify this diagram into simpler manner. See, this is 10 volt. This is 10 kilo ohm. This part, this is 10 kilo ohm. Okay, and this is open, na? This is open. So whatever current will come from here, it will move or it will enter into this R. So this 10 and R will be in series. All right. Now after that, this 10 will come. Okay, so this point is A, this point is A, and this point is B, and this is open. B I have taken positive, and this grounded part I have taken negative. Sorry. Done. And after that, there is a ground connection. All right, now I am supposed to find this voltage V1. Done. Now at this particular point, let us assume that the voltage V0 will be V0 dash. Means for the case 1, I have taken the voltage here V0 as V0 naught, and I will definitely going to apply the superposition theorem because we are going to have two cases. All right. So the polarity which is given as plus and minus here. Now let me take the total current as I, this current as I1, this current as I2. All right. Now how to find this current? Everybody please let me know. Just a second. Okay, how to find this total current? This total current I will be equal to 10 divided by, means 10 volt. Now see, this R is what? This R is given in the question as 10 kilo ohm. Na? Let me check here. This is 10 kilo ohm. Okay, that is 10 kilo ohm. This R is 10 kilo ohm. So see here, this 10 and this 10 and 10, this 10 and this 10 will be in series, and this series will be parallel to this 10K. So 10K parallel with 10K, and it will be, sorry, this 10 and this 10, this will be 20, extremely sorry. This 10K and this 20K will be in parallel. All right, and after that, the parallel combination will be in series with this part. Plus 10K. If you are not getting this, please let me know. I will explain in some different way. All right, this is very conceptual question, and mind you, this will test your patience. All right, now moving ahead. So this will be the total current we are supposed to get. All right, so may I have the answer for this part? This is coming as 0.6 milliampere. You can check also 0.6 milliampere. This is plus minus 10 volt. All right, Rupesh, Saurav, Jayprakash. Now moving ahead, this I will be 0.6 milliampere. All right, now I need to find this V1. So for that, how we will going to find, how we will going to check? All right, now see, let us find the I2 current. Which current? I2 current. This I2 current will be equal to what? Total current I into opposite is 10 kilo ohm divided by total or sum, which is 30 kilo ohm. So this value will be equal to 0.6 divided by 3. This is equal to 0.2 milliampere. All right. Now next, apply the KVL. Apply the KVL in this path. Apply the KVL in this path. So here current I will be in this direction, the total current I, isn't it? Because no current is going here. So I am my assumption direction and this current direction both are negative. So KVL in inner loop. So what is inner loop? This loop. So minus 10 K into I plus, not plus, here the I2 current will be in this direction and my assumption direction is opposite to the current. So minus I will take, minus this 10K into I2, 10K into I2, then plus V1, this is equal to 0. Any doubt in this? Everybody? Do you have a doubt? Please let me know. All right, so minus 10K I minus 10K I2 plus V1. So from here V1 will be equal to 10K into 0.6. So 6, it will come 10K into 0.2. So this will be 8 volt. All right, this is 8 volt. This means that whatever voltage at this particular supply value plus 10 volt, the genre will have the voltage as 8 volt. The genre will have the voltage at 8 volt. So it means that, see here everyone, it means that the genre has to break down at voltage 8.3 volt, but your voltage has been stuck to 8 volt only, has been stuck to 8 volt only. This means that this region is belong to open circuit region. And our assumption is correct. Means we have assumed that this is has to be in open circuit condition, and our assumption is correct. All right. So this diode will be, sorry, this general diode will be open. Now let us find the V naught dash, because our task is to find the voltage waveform across this resistor. So what is V naught dash? V naught dash. See here. This V naught dash is what? R into I2, but the current direction is the opposite to the direction which is given in the question. The plus will come here if the current direction is in this manner, but this I2 current is opposite to the assumption direction. So this V naught dash will be equal to minus I2 into R. What is I2? I2 is 0.2, and what is R? 10. So this is equal to minus 2 volt. Done? Any doubt in this? Everybody please let me know. Any doubt in this? Shall we move ahead? All right. So this was about the case 1. Now let me take the case 2. All right. So this is the case 1. So in the case 2, V naught 2, or sorry, not V naught 2, V naught 1 will be equal to minus V set, and in the question this minus V set is minus 10 volt. Minus 10 volt. Done. So this means that this figure is going to simplify like this. Minus 10 volt plus 10 volt will have the polarity this. Minus 10 volt means what? The polarity will be reversed. So if you want to use this notation, you can use this also. Otherwise, it is better to use this. Both are same. Both are same. All right. Now, see here, everyone. So earlier, the direction of the current is this due to plus 10 volt. But due to this voltage, minus 10 volt, the direction of the current will be reversed. So now this time the current will go into this direction, will flow in this direction. So if you see at this point, we have a node. So current will split like this. So the direction of the current and the symbol of the diode both are same. The direction of the current and the symbol of the diode both are same. It means that it will act in a forward bias region, and in the forward bias region your Zener diode will act as a short circuit. Am I clear? So this is how we will going to identify the operation, or you can say the region of the Zener diode. So let us move ahead. So since this is short circuited, this is short circuit, what we have, please help me while in drawing the diagram. So this will be 10K. Okay, this will be 10K. This two will become in parallel because this point is B and this point will become B. So these 2 points are same. So this 10 and this R and 10 will come in parallel. All right. So it will be like this. This point is A now. This point is A. So this is 10K and this is resistor R. All right. So with A we have a positive polarity and with B we have a negative polarity. So where will B come? B will come in parallel to all this combination. Okay. So this point is B and this is this value 10 kilo ohm. All right, do we have a doubt in this diagram? Please let me know. Rupesh, Saurav, do we have any doubt? This two diagram, this diagram and this diagram, both are same. All right. Now, we need to find the voltage V0. But for the case 2, let me take this voltage as V0 double dash. So this is plus and B will be negative. With B point, the negative is attached. Done. So how to find? Let us take the total current as I. Total current as I, and it is split into two parts. Okay, let me take this as I1 and this as I2. All right, and here let me take this as I3 and this as I4. Done. Now let us find the total current here. Let us find the total current I. So I will be equal to total voltage minus 10 volt. All right. So this 10 and this 10 will be in parallel. So let me write this first. This 10 and this 10. 10K parallel with 10K. Done. This parallel will come in series with this 10 plus 10K. And this overall is in parallel to this 10. Parallel to this 10. So this will be the total current. And let me write the value directly. You will get minus 5/3 milliampere. Done? Clear? I need to find this V naught double dash. V naught double dash is basically what? Right here, V naught double dash will be equal to I4 into R, na? I4 into R. So I need to find the I4 value. So for that case, I require I1. I require I1. So how to find I1 here? I1 will be total current into opposite resistance. Sorry. Opposite resistance, which is 10K. See here. I1 opposite 10K and sum of the resistance. So 10K plus 10K and these two parallel, all are added. So 10K plus 10K plus 10K parallel with R. R is what? 10K. R is what? 10K. So when you solve this, you will get the value. Let me write it directly. Minus 2/3 milliampere. Done. Next, we got I1. Now let us find the I4. So how to find I4? I4 will be equal to I1 current into opposite resistance, which is 10K. Sum of resistance 10K plus R. R is 10K. R is 10K. So from here it will become minus 1/3 milliampere. So V naught double dash will be equal to minus 1/3 milliampere and R is what? 10 kilo ohm. So this will come minus 3.33 volt. Done. Any doubt in this? Any doubt in this? All right. Just a second, everybody. Let me draw the axis first. Okay. So this is V naught. Done. What is this what is this time period? This is the same time period, T/2. The time period of I-stable multivibrator. Okay. Because this input signal plus V set and minus V set is what basically depend upon the time period or the charging and discharging period of the unstable multivibrator. So this V naught will also have the same time period, T by 2, T by 2. So for this reason 1, or you can say for the case 1, not a reason 1, for the case 1, what was your output? Your output was minus 2 volt. Done. So for case 1, your output was fixed to minus 2 volt, like this. Now once the input become minus V set, your output now will be minus 3.33. Done. So this is what? Minus 3.33 volt. Clear? Now what next? This cycle will repeat. Done. Any doubt in this? So let us say in which option we are getting. We are getting minus 2 volt, minus 3.33 volt. All right. So which is given in option B. So option B is the correct option for this question. So please do not worry about this time period T1 and T2. Basically T1 and T2 is what? T by 2 and T by 2. All right. So the correct option for this question is option B. Now let me take this question one step further. Here it is mentioned that the meter is that the voltmeter is PMMC. Now what is the value of the meter when we are when we are using this PMMC? What is the output voltage which is going to be displayed by the PMMC voltmeter? Anybody? Anybody? So just a second, let me add a page. Okay, so output means we have done with the solution part. I am taking this question one step up further. All right. So output V naught is measured by PMMC. Okay. So PMMC meter, it reads average value. So what is average value? See here, if you have a function f of t, and if you want to find the average of this function of this average function, then what you need to do? You need to integrate this function over the time t whole divided by the time period. Or in another way, what you can do? You can find the area under curve whole divided by time period. Integration means what? Area under the curve, na? So if you look into the figure, minus 2 volt is for T by 2. So from here we will going to get a rectangle which is having an area, length into breadth. Am I clear? So V average, this is equal to what? Minus 2 into T by 2. This is area of the rectangle. Not into, here plus will come. Plus minus 3.33 into T by 2 and the total time period. If you solve this, what we are supposed to get? Minus 2 minus 3.33 will be minus 5.33 whole divided by 2. So you will get minus 2.665. Everybody please check whether we are getting the same answer or not. So the average value of the output of the, or you can say the average value of the resistor 10 kilo ohm, which is measured by the PMMC, will be this one. All right, any doubt in this? So this question is very, very conceptual, and you can say, you can rate this question out of 5 as a 5. All right, so did you like this question, everybody? Did you like this question? So let us move ahead with the next question. This one. All right, so this is numerical answer type question. And again, this question is from CRO. Now, read the question very carefully and try to find the answer. The following Lissajous pattern, this is a Lissajous pattern, was observed on the CRO screen as shown beside for the two input signal Vx of t and Vy of t. Done. Given to X and Y plates of the CRO. Sensitivity Sx equal to 1 division per volt and Sy 1 division per volt. If both the inputs are applied to the circuit given below, then the output voltage V0 is dash volt. Rounded up to 1 decimal places, consider diode and op-amp as ideal. So this is the CRO's diagram which is given to me, and I need to find the output voltage V0, where input Vx and Vy are given to this op-amp. Again, this is a question consisting of two subjects, analog and measurement. All right, so let me directly solve this question. Now see here, everybody see here. If you shift this figure, this is what this is Lissajous figure. This straight line. This straight line is a Lissajous figure. Now, if you shift this Lissajous figure like this, passing through origin, then your Vx of t will be what? Vm sin omega t. So this is what? This is reference signal as given in XY plot. This Vx of t is Vm sin omega t, which is the reference signal. All right. And what about Vy of t? Whenever, see everybody, whenever your phase angle between the Vx and Vy voltage, between the Vx voltage and Vy voltage is 0 degree, then you will going to get this diagonally straight line figure. So phase difference means Vm sin omega t plus phi. So this phi is what? This is the phase angle of this Vy. Okay, so this we are supposed to find. All right, this phi we are supposed to find. But if this phi is 0 degree, then you will going to get this straight line, this red wala. So this means that here phi is 0 degree. Done. All right, but my actual figure is this. This one. So this is a reference signal. I cannot change this reference signal. Because with this reference signal, I need to find the phase angle and the Lissajous figure. So whatever Lissajous figure I am getting from the two signals Vx and Vy is due to this Vy only. All right, we cannot add an element to Vx. Whatever Lissajous pattern we are getting like this is only due to this voltage. Okay. So here this Vm is unknown. So how to find? See, when you shift this one like this, it will cover two division. Division horizontally and two division vertically as well. So if you look into the question, we have a deflection sensitivity given as 1 division per volt and Sy is 1 division per volt. This means that for 1 division in X input, we have 1 volt. Then for 2 division, we have 2 volt. Same for Sy also. Am I clear? So what this implies? This implies that 1 division give you 1 volt and this S and Xy both are same. If you look into the diagram, this figure will consume the 2 division. This means that Vm will be 2 volt. All right. So from here, Vx of t will be 2 sine omega t, and Vy of t is 2 sine omega t. But my friend, if you see, suppose this was your earlier diagram, means this is the diagram, or not a diagram, it is not a correct way to say the diagram. This is the Lissajous figure which we are getting for this 2 signal, but my actual figure is somewhat up, or you can say it is somewhat scaled upward to the vertical axis, but it is scaled by how much division? It is scaled by 2 division. Am I clear? It is scaled by 2 division. This means that since 1 division is 1 volt, then 2 division will be 2 volt. So this Vy will have one extra term as plus 2. Clear? So if you have Vy of t like this voltage and Vx of t like this voltage, you will be having this Lissajous figure. Clear, everybody? Any doubt in this? Done? Now, this 2 voltage we are applying at this part and this part. Here Vy of t is 2 plus 2 sine omega t, and Vx of t is 2 sine omega t. This we have obtained. Now what I did, I have taken only this part. And I need to find the voltage here, which is V01. And this V01 will act as an input for this op-amp. So I have divided the op-amp into 2 parts. So let us find voltage here. What voltage we are getting? Let us take this as V01. So how to find this? Everybody please let me know. Let us take this voltage as V1. Now if you apply the KVL, when you apply the KVL here, since the op-amp is ideal, so we have here 0 ampere and 0 ampere. This is V1. This is V1. Now apply the KVL here at this node. V1 minus Vx of t whole divided by R plus V1 minus 0 whole divided by R plus 0 ampere, because of the ideal op-amp. So what value of V1 we are getting? We are getting Vx of t by 2. Everybody, it is clear? We are getting Vx of t by 2. Now, due to virtual ground concept, this positive terminal and negative terminal voltage will be same. Positive terminal voltage and negative terminal voltage will be same. This means that this node will again have the voltage V1. Okay. Now apply the KCL at this node. What we get? We get V1 minus Vyt whole divided by R plus V1 minus V01 whole divided by R. Sorry, this is not 2, this is R. This is R here, and this 0 ampere plus 0. Let us solve for V01. V01 will be equal to what? Everybody please let me know what value we are getting. We are getting 2V1 minus Vy of t. Alright. So V1 is Vx of t by 2. So 2 will be cancelled out. We are left with Vx of t minus Vy of t. So this is the V01 value. that we are getting from the first op amp. Done. Now moving ahead. So this value is basically what? V01. This value. Okay. So this is V01 we are getting, and the rest will be this op amp. Now, one thing need to be very clear here, that we have a diode. We have a diode. So the operation of the diode depend upon the voltage across it. So if the voltage is positive, it will act in a forward bias region, and if the voltage is negative across the diode, it will behave as a reverse bias region. Behave in a reverse bias region. Am I clear? So for that, how we will going to check the diode means the condition of the diode, whether it is in a reverse bias or it is in the forward bias? Anybody? Do I have an answer? Okay. Anyway, the other way of identifying the output is that, means those who know the analog very well, they come to know that this is a precision diode. This is a precision, not a diode, precision amplifier. All right. But anyway, let us find the voltage V0 over here. Now for that, we need to check whether whether both diode are on or both diode are off, or any one will be off or on. Like that we need to find. So let us consider the voltage here as what to take? V dash. Voltage here as V dash. Done. Now look here. We have got the V01 as Vx of t minus Vy of t. Isn't it? We have got this one. What is Vx of t? 2 sine omega t minus Vy of t, 2 plus 2 sine omega t. So this is equal to minus 2 volt. Minus 2 volt. So this V01 is minus 2 volt. Now look at the figure very carefully. The input is acting at the inverting terminal. So for the inverting terminal, the output V dash, not V0, output of this op amp is what? V dash. If this is inverting, means if the input is at the inverting terminal, then output will have the opposite sign as that of your input. If the input is positive, then output will be negative. If the input is negative, the output will be positive. So if you look V01, it is negative, then due to inverting op amp, output V dash will be of opposite sign from its input. This means that V0 dash is greater than 0. So it is positive. It is positive. So V0 is positive. This means that plus will come here, plus will come here. If this is the plus, negative will come here and negative will come here. Now if you see, let us take this as diode D2 and this is diode D1. So the symbol for the diode 1 is opposite to that of the polarity. This means that this diode is reverse biased. And for this diode D2 will have the same polarity as that the symbol we have. This means that this is forward biased. So if you draw the equivalent diagram for this, just a second. Here we have a resistor. Here we have a op amp. This is plus, this is minus, this is grounded, and this is minus 2 volt. This is R this is 5R, and this is open. This diode 1 is open. And this is short circuit because this is forward bias. Okay, this diode 2, and this is diode 1. All right, and we have a output V0 here. And what else? What else? We have a upper limit as plus 8 volt and lower limit minus 8 volt. Means the saturation voltage. Minus 8 volt plus 8 volt. Means this output voltage V0, this output voltage V0 cannot be more than plus 8 volt or cannot be less than minus 8 volt. Less than means minus 9, minus 10, like that. All right. So let us find this output voltage by using this input minus 2 volt. So, sorry, this will be plus and this is negative. Extremely sorry. Done. So how to find V0? Let me take this as V0 1 we have taken. Na? V0 by V0 1. This is inverting op-amp. V0 by V0 1. This is equal to feedback resistor, which is 5R, and this forward path resistor R, and negative sign because of this inverting op-amp. Am I clear? So when you solve this, V0 will be equal to minus 5 into V0 1. V0 1 is minus 2. So this is equal to 10 volt. But your output of this op-amp cannot exceed this 8 volt and minus 8 volt. And here we are getting the V0 as plus 10 volt. This means that this voltage is never possible to get, if we get this 10 volt, this means that it will never possible. Your output cannot exceed the plus 8 volt. So what it implies? That your output voltage V0 will going to be fixed as plus 8 volt. Will be fixed at plus 8 volt. Am I clear? Why this is not valid? Because your output voltage is maximum as plus 8 volt and minus 10 volt, and with this formula we are getting plus 10 volt, which is not at all possible. So your output voltage will be fixed to plus 8 volt. So the answer which you need to put here, which you need to be feed here, is plus 8, and which is the correct answer for this question. Am I clear, everyone? My dear student, please share the session, guys. Please share the session and like the session and share as much as possible. All right. So let us move ahead with the next question that we have in our bucket, which is this NIT type question. Now this question is again a combination of the two subjects, digital. As you look here, this is a counter type of question, which is given or which we used to study in the digital circuit. So basically this question is a combination of the measurement and the digital circuit. All right, now read the question and try to give me the answer. For the two sinusoidal signal whose frequency are Fy and Fx respectively, the following Lissajous pattern was obtained on CRO screen as shown below. So this is a CRO screen, and inside to the boundary we have a Lissajous figure. So here we have Fy signal and here Fx signal. The value of n for the cascaded counter shown below is. So this is mode n counter, 4-bit Johnson counter, 5-bit Ripple counter. All right. So we need to calculate this n value. This n value. How to find this? How to find this? So by looking into this this diagram, this Fy and this Fy, both are same. Both are same. So first we need to find this Fy. So how to find this Fy? Using the same concept, vertical cut and horizontal cut. So Fy by Fx, this is equal to Fx, horizontal cut will be at the numerator and vertical cuts at the denominator. So this is the boundary. Okay, this part is the boundary. So how many cuts we have? 1, 2, 3, 4. 4 cuts in the horizontal. And what about the vertical? 1, 2. So this Fy whole divided by Fx is given to us. Fx is 500 hertz. 500 hertz. So your Fy value is what? 1000 hertz. So we have obtained the value of Fy as 1000 hertz. Am I clear? Any doubt in this? So let us move ahead. Now how to find the value of mode n? So for that you should know the concept of the mode n counter, 4-bit Johnson counter and 5-bit ripple counter. Means the output of mode n counter will be this one. Means if the frequency is this, what will be the frequency of the output? Let me take this output frequency of the mode n counter as F1. Again, this F1 frequency will act as the input to this 4-bit Johnson counter. Let us say the output for 4-bit Johnson counter is F2, and this F2 will act as the input to 5-bit ripple counter whose output is Fy, and this Fy we have calculated as 1000 hertz. All right, my dear friend. Now see here, if you have mode n counter with an input frequency, let us take this frequency as F. Let us take this frequency as F, and the output of mode n counter as F1. So your F1 frequency will be equal to F input frequency divided by the mode. The mode value is here n. So this will be your output frequency of the mode n counter. All right. Now let me take the Johnson counter here. Johnson and Johnson, isn't it? So let me take here 4-bit. Let me take here. Let me generalize the frequency here, the output frequency for n-bit Johnson counter. N-bit Johnson counter. Now let me take the frequency here F1, and the output of the Johnson will be F2. Then F2 will be what? F2 will be, look at here, F2 will be equal to F1 whole divided by 2 into the number of bits that we have taken here, which is n. So F1 divided by 2n will be the output for the Johnson counter. Done? Now 5-bit ripple counter. 5-bit ripple counter. Let me generalize the thing by taking m-bit ripple counter. So here input, let us take F2 and here Fy. So your Fy output frequency of the m-bit will be equal to input frequency F2 whole divided by 2 to the power m, the number of bits that we have. Earlier we have 2 into n. This is not in the power. This is 2 into n. And right now we have 2 to the power m. Clear everybody? Any doubt in this? Now this Fy, this is equal to 1 upon 2 to the power m into F2. F2 is what? Sorry. F2 is what? F1 upon 2n. F1 upon 2n into, or you can say 1 upon 2n into F1. And what is F1? F1 is F by n. So let me replace this with 1 by n into F. Done. So this Fy we have calculated as 1000 Hertz 1 upon 2 to the power m. So m here is 5. N, small n, is 4. So 2 to the power 5 into 1 upon 2 into 4 into 1 upon n. This we need to calculate. And input frequency is given as 3.072 megahertz. 3.072 mega means 10 to the power 6. Alright. So here n will be equal to 3.072 into 10 to the power 6, 1000 into 2 to the power 5 is 32 into 2 into 4, 8. Anything else? Alright. So when you solve this, you will get the value as 12. Am I clear, my dear friend? Any doubt in this? So the correct answer for this question is 12. So I hope you have liked the question, and definitely some part or some concept of this question you will be going to have in your GATE exam. So moving ahead with the next question. This is from the Q meter, which is chapter 6. This is only for the IN stream, not for double E stream. Alright. And in that the important topic is measurement of self capacitance of the coil, measurement of self inductance of the coil, and measurement of the internal resistance of the coil. So let us read the question. This is MSQ type of question, where a Q meter is supplied with an oscillator having 100 millivolt input voltage. While the testing an inductor, the voltage across Q voltmeter is obtained as 10 volt with resonating capacitor adjusted to 200 picofarad. The distributed capacitance of the coil is found to be 10 picofarad. The frequency of the resonance is 50 kilohertz. The Q factor and the inductance of the coil is R. So we need to find which of the following option is R correct. Now let me write the data so that you can have some idea that how to solve this question. The oscillator will have 100 millivolt as an input. So let me take V in as 100 millivolt. Done. While testing an inductor, the voltage across Q voltmeter is obtained as 10 volt, which is obtained at resonating capacitance. Resonating capacitance means, or you can say the resonating condition means, the voltage across capacitor will be maximum at that time. Means in the resonating period, the impedance will be minimum. This means that the current will be high and the capacitor voltage I into X will be maximum. So this VC will be equal to 10 volt. Basically, let me write Vmax because it is mentioned this is resonating capacitance, and this is occurred for the capacitor value C 200 picofarad. 200 picofarad. Now the distributed capacitance is given as CD is given as 10 picofarad. Done. And the resonant frequency is 50 kilohertz. So we need to calculate Q factor and inductance. So how we will going to find this one? Anybody? Now see, the Q factor will be equal to Vc max capacitor voltage divided by input voltage. What is capacitor voltage? 10 volt divided by input voltage is 100 millivolt. Let me check. Yes, 100 millivolt and capacitor voltage is 10 volt. All right, now on solving this, we will get the answer as 100, I guess. Okay, so the correct answer for Q is 100, which is given in option A. Now let us find the inductance. Inductance L, if you know the formula, we can directly use this as 1 upon omega square C plus CD. This is the inductance formula that we have from our Q meter. Okay, so that formula I have directly taken from those chapter. All right. So here L we need to calculate. So 1 upon omega is 2 pi f. F is 50 kilohertz. Na? Let me see. 50 kilohertz. So sorry, 2 pi omega is 2 pi f. So 50 into 10 to the power 3 whole square into C plus CD. So C is what? Resonating capacitance. This is given as 200 picofarad and CD is 10 picofarad. So this is 210. Na? C plus CD will be 210. Pico means 10 to the power minus 12. All right. So on solving this, you will get the answer as or value as 48.25. 48.25 millihenry. So from the option 48.25 is given in option C. So the correct answer for this question is option A and C. This is a basic question, means the IN student can expect the question from this topic, and the question is definitely related to this format only. All right. So any doubt in this? Do we have any doubt in this? No? All right. So let us move ahead with the next question. Is from the current transformer, and this is important for IN as well as EE. The important topic is ratio error and phase error in CT. This is again MSQ type of question. Read the question very carefully. A CT means current transformer, having 1 ton primary is rated at 500 by 5 ampere, 50 hertz with an output of 15 volt ampere. At rated load with non-inductive burden, the in-phase and quadrature component referred to the flux of the exciting MMF are 8 ampere and 10 ampere respectively. The number of turns in the secondary is 98, and the resistance and the leakage reactance of the secondary winding are 0.35 ohm and 0.30 ohm respectively. Then which of the following option are correct? So we need to check the we need to find the ratio error as well as the phase error. All right. Now let me write the data first. Just a second. Okay. Now let me write the data first. The primary turns NP, this is equal to 1 turns. This is given in the question. What next? Secondary turn. This is given as 98. And what else? What else? 500 by 5 ampere. 5 ampere. So this rating are given. So this is basically what? This is the primary rating and this is the secondary rating. So here CT is means here the CT what work it is doing? It is converting the high current to the lower current such that it can be measurable by the an ammeter. Am I clear? Any doubt in this? Done? So let us move ahead. What else we have? We have output as 15 volt ampere. This is the output. Frequency is 50 hertz. What else? The in phase and the quadrature component refer to the flux. In phase means the flux which is generating or producing as a working flux. So this is basically MMF of the magnetizing current, MMF due to the magnetizing current. So this is what? This is due to the I mu, which is equal to 8 ampere. This is directly given in the question, 8 ampere. And what about quadrature to the flux? Quadrature to the flux means what? This is the current which produce the core loss. So here, let me write here, I mu is 8 ampere and core loss current is 10 ampere. This is given in the question. And any more information? Yes. Secondary turn that we have already written, resistance and the leakage reactance of the secondary winding. Okay. So that R2 is 0.35 ohm and X2 is 0.30 ohm. And what else? Load is, just a second. Load is purely resistive. How I come to know? See, the at rated load with non-inductive burden. Rated load with non-inductive burden. So what do you mean by burden? Burden in current transformer is used for load. So non-inductive means it has only resistance. It has only resistance value. So load is purely resistive means ZL is RL. Done. What next we have? Done. All right. So we need to find the ratio error. So let us write the first ratio error formula. This is equal to Kn, sorry, not that one, Kn minus R whole divided by R into 100%. Where R is what? R is small n, this is turns ratio, plus IC cos del plus Im sin del whole divided by secondary current. I have IS, this IMU is basically what? This IMU, this IMU is IM. Means you can write IMU here also, both are same. So I need N value, IC, this is given, IM is given, okay, del is unknown and IS is unknown. So if you look into the question, at rated load, so this is the output at the rated condition, This is the output at the rated condition. Please find fast. Okay. So this small n, this is known as turns ratio. Small n is turns ratio. So turns ratio is what? Ns by Np. So secondary turn is 98 divided by 1. So this is 98. Now at rated, this IC, this IS is 5 ampere. At rated, IS is 5 ampere. That is the secondary current. Now how to calculate del? This del is angle between E2, this is the angle between E2 and I2. So look at here, at rated load, or you can say burden, which is 15 volt amperes. Can I say this is equal to I2, or you can say IS square RL, because this is a load, or you can say burden. So IS, this 15 volt ampere is at the rated condition. So IS is what? 5 ampere. If you look into the value 500 by 5, these are the rated value. So this is for the primary side and this is at the secondary side. So 5 square into RL. So from here RL is equal to, let me write it directly, 15 upon 25 multiply by 4, you will get 0.6 ohm. So we have RL here. All right. Now if you talk about the overall impedance at the secondary side, overall impedance, this is small r2, this is small x2, that is the winding impedance, and the load is resistive. So this is RL. And here we have E2 and this is I2. So can I say E2 by I2? This is what? This is overall impedance. Let us say Z2. So what is Z2 here? Z2 is R2 plus RL plus JX2. So small r2 is given in the question as, it is given in the question, let me see, 0.35. 0.35 plus 0.6. This will be 0.95 plus J. X2 is given as 0.3. So from here, del value is equal to, let me write it directly, or you can say 10 del, imaginary by real. So from here, del value, let me write it directly, from here del value is 17.525, 17.525 degree. All right. So let us calculate the R value. Small n is 98 plus IC is 10, I guess. IC is 10 into cos of 17, cos of 17.525, na? 525 plus IM is 8 sine of 17.525 whole divided by IS, which is 5 ampere. Done. So calculate this value and put in ratio error. Okay, Kn minus R whole divided by R into 100%. So from here you will going to get the R value. So substitute those two value. And what is Kn? Kn is nominal ratio. Kn is what? This is nominal ratio. So this is equal to secondary, this is equal to primary rated current, which is 500 divided by secondary rated current, which is 5 ampere. So this is basically what? This is the ratios, this is the rating of the city. This is the rating of the city. And when you divide those two, you will going to get the nominal ratio. So this nominal ratio is 100. This nominal ratio is 100. So we have Kn, we have R from here. So on solving this, the ratio error will come as minus 0.38%. Okay. Okay, let me give you the value for it. I have this value 100.38. So 100.38, sorry, not 100.38, 100 minus 100.38 divided by 100.38 into 100%, you will get this answer. All right, so let me add one page here. Done. Next is phase error. So phase error theta, this is given by I m cos del minus I m sin del whole divided by NIS. All right. So just swap these two part, these two, and put a negative sign here. Put a negative sign here and remove this n from here and place it in the denominator. Then the formula will become the phase error. Am I clear? Swap this current value, take a negative sign and remove this one and place it here. Okay. So we have IM as the, sorry, this is I. This is I, C sign. Okay. So IM is what? IM is 8 into cos of 17.525 minus IC is what? 10 sin 17.525 whole divided by n is 98 na? N is 98 into and IS is 5 ampere. So whatever value you are getting, that will be in radian. That will be in radian. Now you need to convert this radian into degree, because whatever value which is given in the option, that all are the degree values. So when you solve this, you will get the answer as 0.537 degree. So this is given in 0.537, option C, and minus 0.38. So the correct answer or the option for this question is option B and option C. Am I clear? Any doubt in this, everybody? Do we have a doubt? Done? Let us move ahead with the next question. And this is potentiometer chapter. This is chapter number 8. And the important topic is measurement of voltage. This is very important for the IN stream. The electrical student have the question, means once in a 5 year, or you can say 6 year, like that. But those questions are very, very basics. But for the IN student, this potentiometer question can be clubbed with the op-amp, with the transducer, with the optical fiber, like that. So because of that reason, this chapter has become very, very important for the IN instrument. Sorry, for the IN branch students. Am I clear? So read the question, and this is again a MSQ type of question, where the wiper of, this is not the wiper of your car, okay? So the wiper of the 100 ohm potentiometer. So this is what? This is the 100 ohm, this overall resistance is positioned halfway. The value of the capacitor voltage at t equal to 5 seconds will be 20 volt, minus 20 volt, minus 15 volt, and none of this. So basically, we need to find this capacitor voltage, VC. We have a potentiometer here, and this is a kind of op-amp, and this op-amp will have the input at the positive terminal. So this is what? This is in non-inverting op-amp. This is non-inverting op-amp. Done. And the op-amp we need to consider as the ideal op-amp. So how to find the answer over here, or the solution over here? See, what I will do, I will take this part or this portion, as a load, this portion as a load, and I will apply here Thevenin theorem. Am I clear? I will consider this as a load and will apply Thevenin theorem from this load. Okay. It is given in the question that this portion, or you can say this is a kind of jockey. This is a kind of jockey, and this is position halfway. So if the overall resistance is 100 ohm, so the half resistance is what? 50 ohm. Similarly, this will be 50 ohm. Am I clear? So this portion will look like this. 50 ohm. This voltage is 20 volt. And here we have this 50 ohm. This one. 50 ohm. And we have jockey here. And this we have taken, sorry. And this we have taken as a load. Then let me take this point. Okay. This point as capital A and this point as capital B. So apply the find the Thevenin voltage and the Thevenin resistance. Thevenin voltage and Thevenin resistance. For that, let me change the color first. Okay. All right. So this VAB is what? This is Thevenin, means the voltage across this load. This will be what? 20 volt into this resistor 50 divided by total resistor, which is 100. So this will become 10 volt. Isn't it? This will become 10 volt. What next? RAB, or you can say Thevenin resistor from this side. Short this voltage source. Short this voltage source. So 50-50 will become parallel. So 50 parallel to 50. This will give you 25 ohm. Done. So exactly what is happening here, that you have a Thevenin resistor which is having the value 25 ohm, and this is a load, na? This is a load, and you have a Thevenin voltage as a 10 volt, I guess. So this is this complete circuit diagram with a viewpoint of the Thevenin equivalent circuit in together with your op-amp. Done. Now the question becomes simple. See, let us find this voltage first. Let us take this as Vx. So since op-amp is ideal, so the current here is 0 ampere, and again the current here is 0 ampere. And this voltage at the positive terminal will be the same due to virtual ground concept as Vx. I hope this is clear to you. The virtual ground concept means the current entering into the op-amp will be 0, and the positive terminal voltage and the negative terminal voltage will become same. So this Vx will be equal to total voltage, again voltage division rule, 10 volt into 25 volt divided by sum. This is 50 volt. Again this will become 5 volt. So we have Vx value as a 5 volt. All right. Now at t, what we need to find? We need to calculate this capacitor value at t equal to 5 second. Capacitor value at t equal to 5 second. All right. Now let me draw the figure again. This is minus, this is plus. We have got the voltage as Vx, and here we have a resistor which is grounded, 1 mega ohm. We have a switch and a capacitor which is connected to the output V0, and the capacitor value is 1 microfarad, I guess. Let me see. 1 microfarad, and the polarity given as plus minus Vc. And we need to calculate Vc at t equal to 5 seconds. Now let us assume that your switch is closed for this Vx value. Your switch, just a second, your switch is closed. Oh, extremely sorry. Your switch is closed at t equal to 0. Done? At t equal to 0 second, the switch is closed. And Vx is, we have calculated now Vx, Vx is 5 volt. All right. Now, since the, nice question, sir. Thank you, Vipin. So, since the op-amp is ideal, this means that no current will enter into this op-amp. And by the virtual ground concept, this voltage is again 5 volt. Done. This means that, see here, this is grounded. So, whatever current, let me change the color first. So, whatever current which is flowing from this 5 volt will be in this direction. Na? Sorry, extremely sorry. Okay. So, the current will always flow. The current will always flow from higher potential to the lower potential. Am I correct or not? The current will always flow from higher potential to lower potential. Higher potential is 5 volt, lower potential is 0 volt. So, the current will flow in this direction. Let me take this current as I suffix C. Is this color visible? Yeah, IC. Since no current is entering into this 0 ampere, so this current IC definitely is coming like this, because current can only flow in the closed path. All right. So, this is the IC current. So, can we find this IC value? Can we find this IC value? Yes, we can find. How? See. This 5 minus 0 is the voltage divided by resistor, which is 1 mega ohm. This is equal to IC. So, your IC is 5 microampere. Now, if you see, this 5 microampere is what? This is constant. This is constant. Okay, this is DC value. This is DC value. Again, let me change the color first. Done. All right. Now, let us find the capacitor voltage. Let us find the capacitor voltage here. So, for that, what we can do? What we can do? Now, see this polarity, plus minus Vc. This plus implies that current has to enter or current has to flow in this direction. But actual current direction is this one. So, if this is IC, then minus IC will be here, will definitely flow in this direction, such that it can follow or it can justify its polarity. Am I clear? Any doubt in this? Plus Vc means the current direction has to in this manner. But in the question, we have found that the direction of current is like this. So, this Vc will be equal to what? For the this capacitor voltage, this is 1 upon C integration minus infinity to t IC of t dt. So, 1 upon, sorry, V0 minus initial voltage of the capacitor 0 to t 1 upon C IC of t dt. Sorry, IC of t dt. Initial voltage is what? This is 0. Done. Let me add the page. So your V C of t, this is equal to what? 1 upon C, which is 1 into 10 to the power minus 6, integration 0 to t. IC is what? IC current, this is 1 microampere, na? 1 into 10 to the power minus 6. But to justify this polarity, the IC must be negative. Here IC is what? Plus 5 microampere. Then for this direction, it should be minus 5 microampere. So minus, for that we need to take into dt. Now once you're going to integrate this part, sorry, this is 1 or 5. Sorry, 5. This is 5. Okay, so once you solve this, you will get the capacitor value as minus 5t. Minus 5t. Done? Any doubt in this? Done? Clear? Now at t equal to 5, this value is minus 5 into 5, which is minus 25 volt. This is given in the option D. And if you mark the option D, you will going to get the negative marks, because this minus 25 volt is not the correct answer for this question. Then what is the correct answer, my friend? If you look into the figure here, if you look into the diagram, your plus V set and minus V set is what? Plus 20 volt. Here, this is plus 20 volt and minus 20 volt. Means your output voltage cannot exceed this plus 20 volt or minus 20 volt. Now if you apply, if you see this VC value, if you see this VC value, this VC is what? This is the voltage difference between this point and this point. Okay. Okay, just a second. So let us find the V naught for this capacitor voltage, whether with this value we are getting the voltage less than 20 volt or not. So your VC of t, this is equal to Vx, sorry, Vx will be positive and V naught will be negative. Vx minus V naught. Vx is what? Minus 25. And Vc of t at t equal to 5 seconds is what? Minus 25. Vx is fixed as 5 volt minus V naught. So what is this value V naught? V naught is become 30 volt. And this 30 volt is never possible with this circuit diagram, because your output voltage has been fixed to plus 20 volt and minus 20 volt. This means that this capacitor value is wrong. Am I clear? Any doubt in this? Then what will be the value for the capacitor? So for that, what we need to do, we need to fix the voltage, means exactly at what particular capacitor voltage your output voltage is reaching to the 20 volt. Means exactly at what particular voltage your output is reaching to, means at what particular capacitor voltage your output is reaching to 20 volt. So let me fix this Vx, this Vx has been already fixed, which is at the 5 volt minus. Now I want to find that particular value of capacitor at which the output voltage reaches to plus 20 volt. If you do so, you will get capacitor voltage as minus 15 volt. Minus 15 volt. Am I clear? Now, what will be the time? What will be the time such that it reaches minus 15 volt? We have the equation for capacitor as minus 5t. Minus 5t. So this will be minus 15 volt. So from here, t value will be 3 seconds. Will be 3 seconds. Am I clear? So if I draw the waveform, now everybody please look at here. If I draw the waveform, Vc of t, so from this diagram, sorry, from this equation, at t equal to 0, we have 0 voltage. Okay, and it is decreasing, or you can say it is increasing in negative direction with a slope of minus 5. With a slope of minus 5. And let me take this as t equal to 3. So this value is basically what? Minus 15 volt. And after that, let us draw the output voltage V0. See what is happening here. Everybody, please understand this waveform. At t equal to 0 second, your V0 will be what? Vx only. At t equal to 0 second, this Vc is 0. So this V0 will become what? Vx only, na? So Vx is 5 volt at t equal to 0. Now this voltage is going to increase. At t equal to 3 second, this will become 20 volt. And after this, your output voltage will be fixed. Means there will be no increment of the output voltage. Then what it implies? It implies that after t equal to 3 second, your capacitor voltage was fixed. So once this capacitor voltage was fixed, then only your V0 value will be climbed to plus 20 volt. Am I clear? Any doubt in this? So after t equal to 3 second, exactly at t equal to 5 second, your output voltage, or sorry, not output voltage, your capacitor voltage is equal to minus 15 volt, such that V0 become plus 20 volt. So the correct answer for this question is what? The correct answer for this question is what? Minus 15 volt. Any doubt in this? Guys, this is very, very important question because this require a lot of a concept related to the capacitor charging and discharging, op-amp, and also the potentiometer. This question is basically the topic related to linear charging of the capacitor. Linear charging of the capacitor. Alright, so let us move ahead with the last question that we have in the measurement. Saurabh Upadhyay, thank you, sir. Okay. That we have a last question for the measurement. Alright, so look at the question and try to find the answer here. The equivalent circuit of a diode during forward bias and reverse bias condition are shown in the figure 1. So this is your figure 1. If such a diode is used in the circuit shown in figure 2, this is figure 2, then the output voltage waveform observed on the oscilloscope will be, assume CRO operation mode as YT mode and deflection sensitivity SX equal to 0.4 division per millisecond and SY equal to 0.4 division per volt. Alright, so we need to find which of the following option A, B, C, D will going to be correct. Alright, so if you see this diode is given as an equivalent circuit for the forward bias condition and for the reverse bias condition. In the forward bias, the diode is replaced with 0.7 volt and the resistor, and in the reverse bias, it is replaced with the open circuit. How I come to know that this is a reverse bias condition? See this symbol here, plus and minus, and for the reverse bias, the polarity is opposite. All right. So we need to check first whether this diode is working in a forward bias condition or a reverse bias condition. All right. Now for that, let me take only this part. Let me take only this part. By assuming your diode is open. Just a second. By assuming your diode is open. So I have assumed that my diode is open. Take this polarity plus minus. Okay. So here I have taken plus at this point and minus at this point. If the VD voltage is negative, means while solving, once we going to solve, if we find VD coming as a negative, this means that this is reverse biased. Or else if you assume this polarity in a minus and plus, this implies that you already considered this as a reverse bias. So in this case, VD will become positive. Am I clear? So for this polarity, the VD will be positive and the condition will be reverse bias. And if we take this polarity here, for the reverse bias condition, VD will come negative. Am I clear? Suraj Singh, sir, take. All right, so let us move ahead with this part. Let us take the output here as V01. V01. Now, the current here will flow in this direction, which is I. Let us take the current here is I. So V01 will be equal to what? Or else we can directly apply the voltage division rule. We can directly apply voltage division rule. So V01 will be equal to what? Total voltage, which is 10 sine 314t into this voltage, sorry, this resistor, which is 10 kilo ohm, whole divided by total resistor, which is 20 kilo ohm. So this value is what? 5 sine 340t. Now this is what? This is omega. This is what? This is omega, which is 314. Omega is 314. So if you find the time period for this, time period will be what? 2 pi by omega. So 2 pi 314. So this will be equal to 20 millisecond. So, or you can say the frequency 50 hertz, which is 1 upon T. Done? Am I clear? Am I clear? Now let us find the VD equation so that we can check the diode is going to be open or short. So how to find this? See, the total voltage here is V01, isn't it? So your V01 is what? This diode voltage VD plus this voltage 5 volt. So we got the V01 as 5 sine 314t, or VD will be equal to V01 minus 5 volt. V01 is 5 sine 314t minus 5. Minus 5. Now everybody, please answer my question. What will be the maximum value for this VD? Or in other way, whether this VD value will be positive for any value of the sign? Everybody please answer this question. Whether the VD can be, it is possible that VD can be positive for any sign value? No. If you see here, your sign will have the maximum value as +1. and it will go up to -1. If you take +1 here, it will be 0. For sine 314, the maximum value is +1. So it will be 0. And for -1, it will be -10. So for all value of sine, your VD will always less than equal to 0. Always be less than equal to 0. This means that your diode will always remains reversed bias. Always remains reversed bias, and this implies diode will be open circuit. So whatever assumption we have made, that is correct. All right, any doubt in this? Surat, Saurav, Vipin and others also? All right. So if you see here, we have got the V01 expression. Now this V01 will pass to this 1 upon pi t. This V01 is passed to 1 upon pi t, and after that we are having output voltage V0. Now this 1 upon pi 2 might be new to you, but definitely you have seen this 1 upon pi 2 form. So my question is, where you have seen this 1 upon pi 2? In which subject you have seen? If you know this, then definitely you will have the answer at your fingertip. Where you have seen? Okay. So this output voltage V0, this is what? This is given as V01 convolution 1 upon pi t. Signal. Excellent, Vipin. Excellent. So if you know this, then definitely you will be having the answer. All right. So this V0 will be what? V01, which is input for this system, convolution 1 upon pi t. Now this 1 upon pi t, in which chapter you have seen? Definitely you have seen in the Fourier transform. So what we need to do? We need to find the Fourier transform in the left hand side and in the right hand side. So let us do that. Fourier transform of V0 t, this is basically V0 t, na? Equal to Fourier transform of V01 convolution 1 upon pi t. So convolution in time domain means in the frequency domain we need to multiply it. All right. So we need to find V01 j omega and Fourier transform of 1 by pi t. So let us find here. This V01 t is what? This is 5 sine 314 t. Let me take 314. Let omega c equal to 314. So V01 of t, this is equal to 5 sine omega c t. Done. Now, do we have the Fourier transform for 5 sine omega c t? Do we have? Yes, we have. Look at here. This 5, do we have? All right. Now see here. This sine can be written as e to the power plus j omega ct minus e to the power minus j omega ct whole divided by 2j's. Simple. Sine theta is what? E to the power iota theta minus e to the power minus iota theta divided by 2 iota. The same thing I have written here. So take the Fourier transform on both sides. What we have? Here we will have V01 j omega. Here 5 divided by 2j. 5 divided by, extremely sorry, 5 divided by 2j. And Fourier transform of e to the power j omega ct minus Fourier transform of e to the power minus j omega ct. Alright, now by using the duality principle 1 into the power j omega ct, by using the duality principle, what we have? Fourier transform for this 2 pi del of omega. If this is plus, here minus will come, and this value omega c minus omega c. All right, am I clear? If you take minus j omega ct, the Fourier transform for this will be what? 2 pi del of, if this is minus, here plus will come, omega c. Alright, so this V01 j omega will be equal to what? 5 upon 2j times Fourier transform is 2 pi, del of omega minus omega c minus, due to this minus sign, 2 pi del of omega plus omega c. Done. So what thing are cancelling over here? 2 will be cancelled out. 5 pi by j del omega minus omega c minus del omega plus omega c. Done. Let me add the page. So this V01 j omega is what? 5 pi j del omega minus omega c minus 5 pi by j del omega plus omega c. So if you plot this one, just a second. If you plot this one, V01 j omega against omega. So this omega minus omega c means when you equate it to 0, it will give you plus omega c. Plus omega c. So at plus omega c, what is the strength? 5 pi by j. So this will be strength 5 pi by j. Positive value, isn't it? And this is what? Minus 5 pi by j. But where? At omega equal to minus omega c, means here, exactly at the same distance. So this will be minus 5 pi by j. Done. So we have got V01 j omega. What about 1 upon pi t, Fourier transform of 1 upon pi t? What will be its Fourier transform? Now, if you have heard the signal as a signum of t, then definitely you will be having your answer. See, signum of t is what? U of t minus u of minus t. This can be also written as 2u of t minus 1. All right. Let me take this signal as x of t. This signal as x of t. So this x of t is basically what? This x of t, signum of t is basically what? It will, if you plot against t, this signum of t, u of t having the amplitude 1 and u of minus t means left hand side having the amplitude minus 1. This is minus 1 and this is plus 1. So this is the representation of the signum. All right. Now, this signum of t can be written as 2u of t minus 1 because u of t plus u of minus t is 1. All right. So I have taken signum of t as x of t. Now differentiate left hand side and right hand side. So d by dt x of t, this is equal to 2 d by dt u of t minus 0. and take the Fourier transform then. Fourier transform will be what? J omega x of j omega here 2 d by dt, or else what we can do? We can first differentiate here d by dt x of t, this is equal to 2 del of t. Let me add the page. So here take the Fourier transform. So this will become j omega x of j omega and 2. What is the Fourier transform of del of t? Minus j sigma. No, it is not. I am talking about the Fourier transform of del of t. That is 1. Am I correct, Vipin? So your x of j omega will be what? 2 by j omega. For 1 upon pi t. Okay, anyway. This is x of j omega. So this is what? This is the, you can say, signum of, means this is a Fourier transform of, yes sir, for del of t, that is 1. So this is the Fourier transform of this signum of t. Alright, so signum, just a second, your signum of t का Fourier transform is 2 by j omega. Done, everybody? Now, by using the duality principle, now here I am using the duality principle. Duality principle says that if you replace omega with t, then by using duality principle, the Fourier transform will be multiplied 2 pi into signum, and t will be replaced with minus omega. T will be replaced with minus omega. So here one more thing, that your Fourier transform is what? It follows linearity. It follows linearity principle. Linearity principle means this 2 and this 2 can be cancelled out. Done. So here 1 upon t, bring this pi to left hand side and this j to right hand side. J signum of minus omega. And one more thing you should know, that I am not going into much detail. Your signum of minus omega is what? Odd function. So x of minus t is what? Minus x of t. So your 1 upon pi t Fourier transform will be, signum of minus omega is minus signum of omega. So this will be minus j signum of omega. Done, clear? Now look at here. This is what basically? This is minus j signum of omega means u of omega minus u of minus omega, just like signum of t. Done. If you plot against the frequency omega this minus j signum of omega, what we will going to get? For positive value of omega we will be having minus j, and for negative value of omega this minus and this minus will become plus. So this will be plus j. Done. Now exactly somewhere in the x-axis we will have plus omega c and here minus omega c. So at minus omega c, what is the strength? Plus j. And at plus omega c, what is the strength? Minus j. Okay, I have already written here minus j. So next what we need to do? We need to multiply because V naught of j omega, this is what V naught 1 j omega into Fourier transform of 1 upon pi t. Now, if you multiply, look at here. If you multiply at minus omega c, we have minus 5 pi by j. So, we have minus 5 pi by j like this. Let me change the color first. I am going to multiply that V naught 1 j omega. So, when you multiply, this will have the strength 5 pi by j, and here we have a strength as minus 5 pi by j. Let me check it once. Minus 5 pi by j plus 5 pi by j. This is minus omega c. Here we have minus 5 pi by j, and here we have plus 5 pi by j. Okay. Now, at minus omega pi by at minus omega c, this two strength will going to be multiplied because of this function. Here, these two functions are multiplied, so we need to multiply this two strength at minus omega c. So, what is the value? Here minus 5 pi by j, here plus j. So, it will become, when you multiply these two, it will become minus 5 pi, isn't it? It will become minus 5 pi. But at what frequency? At frequency minus omega c. So, this will become del omega plus omega c. So, when you multiply these two, at minus omega c, you will have the strength as minus 5 pi. In the same way, at plus omega c, what is the strength? Minus j, 5 pi by j. Again, it will become minus 5 pi, but this time at plus omega c. Done? Any doubt in this? Do we left, just a second. Okay. ठीक है, all right. That is fine. All right. No doubt, sir. Great, excellent. So, from here, if you take the thing common, just a second. Let me have the data first. Okay. Okay, so here 5 pi by j, this 2 will be cancelled out. Okay, great. Okay. So, this will be minus 5 pi and del of omega plus omega c, or you can say pi del of omega plus omega c minus, plus pi del of omega minus omega c. Multiply by 2, divide by 2, like this. Multiply by 2, divide by 2, isn't it? So, this V naught of j omega, just a second, this V naught of j omega, this will be minus 5. So, the Fourier transform of this part will be what? Everybody please let me know. The Fourier transform for this part will be what? Cos of omega ct. Cos of omega ct. Sorry, let me write it directly. Fourier transform of this one is V naught of t. So, Fourier transform of V naught of t is what? I have taken it as V naught of j omega. So, take the inverse Fourier, not the Fourier transform, inverse Fourier transform. You will get this value. Am I clear? So, after that, we have given Sx as a value. Sx is given na? Okay, Sx is what? 0.4 division per millisecond and Sy 0.4 division per volt. Sx is 0.4 division per millisecond and Sy is 0.4 division per volt. Okay. So, this is what? This is the deflection sensitivity, means for a complete division in a CRO, that we need to find. So, what will be the complete division? Since it is given that for 1 millisecond, it is covering 0.4 division and the time period for the signal is what? 20 millisecond. So, for the 20 millisecond, the number of division it will take 8 division. Am I clear? Any doubt in this? Now, come to Sy. This is in voltage. So, for 1 volt, it is taking 0.4 division. Then for 5 volt, see, for 5 volt, I am not considering right now this negative sign. This 5 volt will take what? Multiply with 5, it will take 2 division. It will take 2 division. Now, look at here everybody. We are about to finish this CRO, this measurement subject. This is the boundary of CRO and this is the gratitude. Okay. So, seven and 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Just a second. 5, 6, 7 and 8. And this is the origin. This is the origin. All right. Now see, we need to plot V naught of t as minus 5 sine 340 t. So, in the horizontal axis, we have 8 division 1, 2, 3, 4, 5, 6, 7, 8. And in the vertical, again we have 8 division 1, 2, 3, 4, 5, 6, 7, 8. Now, my signal is minus 5. My signal is minus 5. Minus 5 means in the lower axis. In the lower axis. So, 5 division means, 5 volt means 2 division. So, this is 1 division from here to here, 1 division and 2 division. In the lower part again 1 division and 2 division. Alright. And your time period is what here? We have calculated your time period is 8 division. It will take 8 division. So, how it will going to start? Your diagram will be like this. So, it will start from here, but from negative due to this negative sign. So, it will start like this. Reach plus 5 volt, which is 2 division. Go like this and it will end up like this. So, this is the diagram for minus 5 cos 340T. Done? Any doubt in this? Clear? All right. So I hope you have got the solution, and whatever thing I have taught here is very, very clear to you. All right. So with this, we have completed the measurement subject, and the correct option, I think it is given in the option. Let us check. It is given in the option D. It is given in the option D. All right. So I hope you have enjoyed the session, and if you have liked the session, so please like that one. So next topic, electrical. Yes, the next subject we will going to start from tomorrow. That is electrical machine, and in the first session I will take induction and transformer, and in the later session I will take DC and synchronous. Excellent question you discussed. Thank you, Gopal. All right. So with this, we have completed the measurement subject, and I hope you have enjoyed the session. And if you have liked the session, please hit the like button, and as well as please share the session with the friends so that they also get benefit from this session. All right. So coming back to the features that the IMS GATE Academy have. So these are the features that we have. First, you need to enter into the website. All right, imsindia.com, like that. You will have to enter, and you will come across this the first page, and after that we have a program, classroom program, hybrid, exclusive, self-learning. In the classroom we have this kind of features, in which the whatever classes we have, that is only offline, not the online. All right, 100% offline. Next, in the hybrid we have 750 hours again, but this time 67% will be offline, and the online will be 33%, and rest will be same. Here we have completely live class, that is online class. Here the recorded lecture will be given to you. Again we have LPT methodology. Next, this is the test series that we have. All right, almost 130 plus a test you will be given. All right. Next, this is GATE at zero fee, means when you enrolled these features, then you will going to get this 100 plus hours of content, or you can say concept video, 12 chapter test, 6 subject test, and 6 past GATE paper. So for that you have to be enrolled, and you will not charge a single penny. All right. So enter into this website, imsindia.com. After that, this will be the student portal, where you will going to get the videos, lecture, and PDF of the study material and the test. All right. And this is the doubt solving portal, where the student will post the query or the question related to the subject, and the faculty will reply to the doubt, whatever doubt the student are posting, but that should be technical doubt. All right. And after that, this is the USP of the IMS GATE Academy, that we are taking one-to-one mentoring session, and one-to-many mentoring session, means we are personally engaging with the student. If he is facing any doubt, or she is facing any doubt while doing the preparation, or if he is not able to get any concept related thing, then he can book a slot in that. We will be going to have a one-to-one session and one-to-many session. So this is basically a USP of the IMS GATE Academy. All right. So thank you, and hoping that your GATE exam will definitely going to means you will definitely going to crack the GATE exam with a good number of marks. And again, I am saying this, if you have not subscribed the session, please our channel, please subscribe, do subscribe that, otherwise you will not going to get the benefit of this session that the IMS GATE Academy are conducting. So please tell your friend, your student community to subscribe the channel and come to the live session. Definitely we will going to have the healthy session more and more. And after me, there are almost n number of subjects are pending, so you will definitely going to enjoy that also. All right. So all the best for your futures, and we will meet again on tomorrow's session from the electrical machine subject. All right. Thank you.